Hey everybody, this is Larry. This is day 14 of the April Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. 2 weeks in, give yourself a pat in the back. For 2 straight weeks is tough, but especially yesterday's a bit. Let's see, today's problem is partition list. So I usually solve these live. If if it's a little bit slow, fast forward or watch on 2x or something like that. Okay, so given a head of a linked list, partition so that all nodes less than x come before and okay. Given x, why is 4 before 5 then? Such that all node less than x coming before nodes. Huh? X is equal to 3, so why do we not? Okay, I think I get the idea. It's a little bit awkward, but okay. So the first thing that I'm thinking of is just bubble sort. And in this case, the bubble sort, maybe not bubble sort, maybe it's not even a, I think we don't have to do it in place. I think that's one of my self-imposed limitations, but you shouldn't always have self-imposed limitations unless you have to. And there's going to be a couple of edge cases anyway where for example the first element is bigger than x, then you have to put in the second thing. So okay, I think I'm just going to do it in a, I think there's another way of doing it just to take advantage of the fact that it's a linked list. So the idea is we just have 2 partitions that we can manually focus on. For example, we can do let's just say small half. Small half is equal to list node of -1, big half, list of node of -1, and then we just go through current is equal to head. While current is not none, we just move it forward. Right, this is regular linked list traversal, and then the idea is that okay, if current.wow is it greater than or equal to x, then we put in the big half, right? Well, so we have to keep 2 things actually. So this is small head at the beginning, then small head half tail, say equals small half, and same thing for big half. So here then the big half tail, we set the next is equal to current, and then big half well, big half tail is equal to big half tail dot next. But then what we want to do is, no, I think this is okay. Because what I was going to say is that we have to set the next so that it's not good, but I think we actually set in the next iteration, so we should be good. Else small half tail dot next is equal to current, small half tail is equal to small half tail dot next. Okay, and then at the very end we want to set small half tail dot next is equal to big half dot next, because the big half of course is this sentinel node that doesn't do anything. It's just a placeholder. And then big half tail dot next is equal to none, and then at the very end we return small half dot next. Because again, this first node is just, you know, a useless node that we put here as a placeholder. Let's see if this is good. This looks okay. I mean, I felt okay about it. Is there any possible, yeah, let's make sure that, you know, for example, yeah, I don't know, 1, and then also, I think 200 is the biggest number, am I right? Is that what they say? 100 even? Okay. Just to check the empty cases. Okay, so that looks good. So let's give it a submit. Cool. Yeah, so the key part about this problem is that it's linked list. So it definitely requires some kind of problem solving that you might not be used to, because linked list just doesn't come up in real life as much. And a lot of it, what I've done here is just experience, but figuring out how to, you know, what I call is a loop invariant, which means that I didn't go through this that deeply, but every loop, something has to be held true. And in this case, it is that, you know, big half tail is pointing to the next, and small half tail is pointing to the last of their respective halves, and that, you know, and that both of them, the next is pointing at some garbage that we need to overwrite. Though you can also, I think, set it to, you could have actually done this as well if you want to be explicit about it. No, I don't think you can, because that would set this to be wrong. That's why I didn't do it that way. But you know, that's why we have it here at the very end instead. Let me know what you think. So this is linear time, constant space, if you want to call it that, maybe, because we actually, even though it's not super clear from this code, we actually overwrite the nodes that they give us, which is maybe, I know that usually I don't like doing things in place, but I think for a function named partition, doing in place is actually the expected behavior. You know, your mileage may vary, but this is going to be constant space just because we actually manipulate current pointers, and we only have a couple of extra pointers to facilitate that. It's linear time because we look at each node once. That's all I have for this problem. If you have questions about this, you know, first draw it out. I think visualization is very helpful when it comes to linked lists. And just to look at where each point is pointing at. I messed it up a lot all the time. So yeah, let me know what you think. Let me know about your questions. And yeah, stay good, stay healthy. I will see you tomorrow. And to good mental health, have a great night.